Hey guys, welcome back to STR8CHEM. In this video, we're going to learn on how to describe the formation of line spectrum. To start, let's have a look at exercise number 1. Explain the formation of line spectrum, or a photon. So when you see the term line spectrum, that refers to a photon as well. Okay? Over here, we're going to have 1, 2, 3, and 4 points that you need to be able to write down in order for you to get full mark for this kind of questions in exams. So the first thing you're going to be writing over here is about the electrons at the ground states. N equals to 1 will absorb energy, and it is excited to N bigger than 1, which is higher energy level. So that means for the first point, what you need to be talking about is you need to talk about how the electron, so you have the electron over here. So at this point, this is at the ground state, okay? And then what happened? It will get energy, okay? So you will give some sort of like amount of energy. It will absorb the energy, and the electron will get excited to a much higher energy level. So it may go up until n equals to 2, 3, 4, 5, depending on the amount of energy absorbed by the electron. So this is the first point that you need to write. And then second, what happened? The electron at n bigger than 1, or at excited states, will be unstable, and it will drop to a lower n energy level, or even back to the ground state. Okay, so if this electron going up to n equals to 5, for example, it will be at the excited state. It will not going to be stable, and therefore it will drop to a much lower energy level. And for the third point, the energy is released in the form of photon that corresponds to a certain wavelength. Okay, so when the electron, I'm just going to show you. So if the electron from higher energy level drops to a much lower energy level, energy will be released in the form of photons, and that will have a certain wavelength as well. And then finally, what you need to be right about is this. Since the energy is quantized, it's very important for you to mention the word quantized, a line spectrum will be formed. Okay, since the energy is quantized, a line spectrum is formed. Note that the explanation over here is general because the question is not specific. Exercise number 1, if you read carefully, it doesn't say what sort of line. Is it the second line in Pablo series? Is it the first line in Passion series? And so on. So when you get questions like this in exams, quite general, not specific, you can write down your answer in this form. So, in exams, you would be given this one, you will get 1 mark, and then 1 mark right over here, 1 mark right there, and 1 mark right here. Now, let's have a look at one example when it gives you a very specific line spectrum. Right here, the question wants you to write the explanation, the formation for the second line in brackets series. So you need to remember the end final for bracket series when you want to do this, okay? So if you look at the first point over here, The electron at the ground state, n equals to 1, absorbs energy, and it is excited to n equals to 6. So right now, it's quite specific. If you compare with what we have done over here, because it doesn't state specifically what sort of line you want to explain, you can write in general form, okay? But right now, here, you have second line in bracket series. So you need to mention specifically where the electron from the ground states after absorbing energy to where it will be excited. In this case, it will be excited to n equals to 4. How do you know it's going to be n equals to 4? Because it is on the second line of bracket series. Remember, for brackets, okay, I'm going to use a different colored pen. You have to remember that for bracket series, the n final will be equals to 4. Okay, remember, lemon, Balmer, passion, bracket, fun. Okay, Lyman series, Balmer series, passion series, bracket series, fun series. So for Lyman, n final equals to 1, n final equals to 2, this one is 3, this one is 4, and that one is 5. So you have bracket series, so n final is 4. So when the n final is 4, if you want to explain the formation for the second line, you're going to plus 2, you get 6. So the n initial will be from 6. So that's why it will go up to 6. Okay, from the ground states. Okay, from the ground states, right here, it will absorb energy and it goes up to n equals to 6. Okay, and what happened after that? The electron at n equals to 6 is unstable. It is at the excited state and it drops to n equals to 4. Okay, so this particular electron over here will drop to n equals to 4 and energy will be released. So that will be the photon, okay? So the energy that is released over here will be forming the line spectrum, the photon in bracket series. Okay, and then the third point that you need to write is the energy is released, photon in the form of photon, that corresponds to a certain wavelength. So exactly the same, the green bits over here is exactly the same as what we have written just now in exercise number 1. And finally, since the energy is quantized, a line spectrum is formed. This is the second line in bracket series. So you need to add this bit. Okay, you need to add this is the second line in bracket series. Okay, you be more specific right over here and right over there when the question is specifically for a certain line spectrum. Right. So you'd be given 1 mark for this, that 1, and 1 mark for that. Okay, last one. Exercise number 3. Now you get the idea that every single time when the question wants you to explain how a line spectrum is produced or describe how the fourth line in Passion series or the second line in Balmer series. This is the standard answering formats that you can follow, okay? It will follow the same steps over here. Now, look at the question. The question for this one, it requires you to write or explain how the third line of Balmer series is produced. So you're always going to start with the electrons at ground states n equals to 1, absorbs energy, and it is excited to which n. Okay, again, we're going to use what we have talked about just now. For Balmer series, first of all, you need to think about where is the electron going to be dropping after getting excited. Okay, so Balmer series n final will be equal to 2. So remember, L, P, B, P, L, B, P, Lyman, Balmer, Passion, Bracket, Fun. Okay, L, B, P, B, P. Okay, you can remember in that way L, B, P, B, P. Lyman, Balmer, Passion, Bracket, Fun. So when you look at Balmer over here, it will be the second one. So that will remind you that the end file for Balmer series is going to be 2. And the question wants you to describe the third line. So third line reminds you the number 3. So you're going to plus 3. You get n initial equals to 5. So when n initial equals to 5, that means the electron at the ground states, n equals to 1, n equals to 1 ground states, absorbs energy. It will absorbing a certain amount of energy. It gets excited to n equals to 5 right there. So over here, we're going to put 5. The electron at n equals to 5 is unstable, which is going to be excited states, and it will drop to n equals to 2. It will drop to n equals to 2. Why? Because we're talking about Balmer series. So you're going to put 2 right over here. The energy is what? Photon. The energy is released. Yes. Just like what we have done right over here just now. So the energy is released, or the other word for release is emitted. You can use that one as well. Okay, that corresponds to a certain wavelength. Since the energy is, okay, remember, quantized. A line spectrum is formed. This is the third line. Okay, so that is the third line in Balmer series. Again, you'll get 1 mark over here, 2, 3, and 4 marks.